I'm Bill Mould, and in this very short video I'm going to give you just a peek into the science of carbon fiber composites and how they are used in bicycle rims. It's a very small segment out of the video series I've been creating over the last year, which will delve deeply into the physics, engineering, and mathematics of bicycle wheels. The process begins with polyacrylonitrile, which is shown below, a long polymer. In a two-step process carried out at a temperature of thousands of degrees, the polymer is turned into the structure you see below. And that structure is really graphene, which essentially has the form of chicken wire in its shape. And if I take parallel sheets of graphene and stack them on top of each other, then I have this material here, which is graphite. The graphite, which is found in carbon fiber bicycle rims, gives them a special property, which we will now look at. Let's delve briefly into some chemistry and look at some structures of carbon. This is the crystalline structure of one of the forms of carbon known as graphene. Notice that it's a 6-carbon ring, hexagonal, and all of the 6 atoms are lying in the same plane. Here we see a continuation of that 6-carbon structure spreading out in all directions. So this is a larger piece of graphene. If I take this and I fold it around and form a tube like this, then I have formed a nanotube. Graphite is just a very large number of parallel forms of graphene. So if I start stacking these forms on top of each other, forms of graphene, then I have graphite. Notice that the bonds between the carbon atoms in each of these sheets is very strong, but the bonds between the sheets is very weak. So layers of graphene can slide easily past each other, which is what causes graphite to be rather slippery and is sometimes used as a lubricant. Now, carbon typically makes 4 bonds. Here you only see 3 to any carbon atom. There is a free electron for each carbon atom that spends part of its time above the plane of the graphene and part of its time below the plane of the graphene, and that makes these electrons what we call delocalized and free and movable. And that is what gives graphene, and therefore graphite, a special property. Here's a simple device for determining electrical connectivity. So I have a battery and a light and 2 wires. If I connect the wires, the light comes on, showing that I have completed the circuit. Here's a graphite pencil. Because of the free electrons in graphite, it conducts electricity like a metal, as we can see here. Here's an NV carbon rim, and if I take my conductivity tester, connect it at one point and over here another, you see that my carbon fiber rim conducts electricity because of the graphite in it. You may not have found that interesting, but I thought it was, so I wanted to show that to you. A discussion of the details of why this conductivity takes place is pretty nerdy, but if enough of you ask me to do it, I'll provide that to you subsequently. I hope you liked that little intro. Here's my email address, website. You can follow me on Facebook, and I have a YouTube channel as well.